Okay, I'm going to have everybody go ahead and take out lesson M1. I'm going to have you do a paper copy so that everything that you do you can write down while you're watching the lesson. So if you go to the first slide, you'll see that we're learning about solving systems of equations by graphing. If you read here, it says a system of equations is two or more equations which may have common solutions. So what you're trying to do is you're trying to figure out where the two lines that you graph intersect. So if you're looking down at the bottom, you'll see the graph. You've got line 1 here, which I'm tracing right now. You've got line 2, which now I'm tracing, and you're looking to see where the two lines intersect. With this, you're going to have a variety of possible answers. In this case, they cross in one spot, so it's said to have one solution. If you wanted to give the exact solution, you would have to figure out the coordinate points, and you would list that one solution as a coordinate point. Moving on to the next slide, this is the second type of example. Here you see the two lines, and again we're looking to see where the lines intersect. Do these lines ever intersect? No, they're parallel lines, and so in this case it's said to have no solutions. Parallel lines, which I'm writing at the top, you should write it on your paper. Parallel lines won't intersect. Therefore, no solution. The third case that we're going to have is on the next slide. Actually, it's not on this slide. The third case would be if the lines were exactly the same. And we'll get to that later on in the slide. If you're looking at slide 4, you'll notice that we are going to review graphing lines. The little side note that I want you to put is that you want them to be in graphing. Let's see. Graphing must be done in y equals mx plus b form. I'll move that so you can see it. So if you're looking at the first example, example 1, right here, we've already got it in the y equals mx plus b form. Here is our m, here is our b. Remember that m is our slope and b is our y-intercept, where it intersects the y-axis. So if you look at your y-axis, I'm going to zoom in a little bit. I've got to go to plus 6 in order to graph my y-intercept. So I'm going to go up from the origin, 1, 2, 3, 4, 5, 6, and I'm going to make my mark. Then I look at my slope, which is right over here. It's negative 2/3. So from that point, I'm going to go down 2 and over 3. Down 2 and over 3. Down 2 and over 3. And then I can connect all of those points with arrows at each end. That you should be familiar with. If I move over to the next one, I'm keeping in mind our little note right here. It says graphing must be done in y equals mx plus b form. Since this one isn't in the y equals mx plus b form, we are going to work to get it in the y equals mx plus b form. So I'm going to write my original problem, 3x minus 2y equals 6. The first thing that I want to move to the other side would be my 3x's. So to get them over there, I'm going to subtract 3x's from both sides. Now because I want it in the y equals mx plus b form, I'm going to put my x's before my 6. So I'm going to put negative 2y, which is what's left, equals negative 3x plus 6. It's a plus 6 because it's a positive 6. The last thing I need to do to get y alone would be to divide by negative 2. Remember, I'm dividing everything by negative 2. So I'd end up with y equals, if I broke this up, it'd be negative 3 over negative 2x plus 6 over negative 2. Another way to write that, y equals positive 3/2 x minus 3, or plus negative 3. We could write it that way as well. So then, now we have our slope and our y-intercept. I underlined them as I said them. Since our y-intercept is negative 3, I'm going to mark that first. I'm going to go ahead and zoom in. And my slope is 3 over 2. So from that point, I'm going to go up 3 over 2. Up 3 over 2. Up 3 over 2. And connect with arrows at each end. So that's a review of actually graphing lines when you're given the equation. The most important thing to keep in mind is that graphing must be done in y equals mx plus b form. Moving on to the next slide, it says solve by graphing. Since it says solve, we want to figure out, is there going to be one solution, no solution, or many solutions? So we're going to put them on the same graph in order to see where they intersect. I'm going to start with this one. You always want to check to see if it's in y equals mx plus b form. I'm going to put a little star at the top to help you remember. Y equals mx plus b. And since this one is, you can go ahead and graph it. I'm going to zoom in a little bit so that I am accurate with it. Okay, so I'm looking at my y-intercept, and since I highlighted this one in red, I'm going to graph it in red. I'm going to go up 3 spots, and since my y-intercept was 3, I put it at 3. Now 4 can be looked at as 4 over 1. So from that point, I'm going to go up 1, 2, 3, 4 over 1. I can also go in the opposite direction, down 1, 2, 3, 4 over 1, and just continue the pattern until I've filled the whole page. And I connect with arrows on the end. The second one I'm going to do in blue. I first look at the y-intercept at negative 2. I'm going to make my mark. And then my slope is just a negative x. But remember, if it's written as negative x, there's really a 1 out front, so you could look at it as negative 1 over 1. So from there, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and so on, completing the pattern, and then looking to see where they intersect. Now they should intersect at a perfect coordinate point. And so if you look here, I'm going to highlight it in black. Right here is the point of intersection. So they cross at one point, so there's one solution. And it's at negative 1, negative 1. So to check your answer, if you plug in negative 1 for x and negative 1 for y, both equations should work. So up top with the red one, I'm going to put negative 1 equals 4 times negative 1 plus 3. I'm going to check to see if it works. Negative 1 equals negative 4 plus 3, and it checks out. So that one works. Checking the next one. We've got negative 1 equals negative 1 minus 2. Well, a negative 1, or the opposite of negative 1, would be a positive 1, and 1 minus 2 is negative 1, so it works. That's an example of one solution. Moving on to the next page, we're going to plot these as well. I'm going to go ahead and zoom in the best that I can, and I'm going to plot the first point in red. At 1, I'm going to make my y-intercept, and from there I'll use my slope to go up 1, 2, 3, and over 2. Up 1, 2, 3, and over 2. I'm going to just keep continuing on with the pattern, 1, 2, 3, over 2. And connect them. The next one I'm going to plot in blue. I've got a y-intercept of negative 3, so negative 1, negative 2, negative 3. Make my mark, and my slope is, remember, we like to extend this line across and bring the negative to the top. Just makes it easier to look at, and so we don't forget that negative sign. So I'm going to go down 1 and over 2. Down 1, over 2, down 1, over 2, and then I'm going to connect my lines, and see where they intersect. In black, I'll highlight the intersection, and it looks like we have one solution, or one intersection, which is at negative 2, negative 2. If you wanted to check your work, you'd go up, you'd do 3/2 times negative 2 plus 1, and see if you get negative 2. Well, the negative 2 and the 2 can cross off, become negative 1, so that becomes negative 3 plus 1, which is indeed negative 2. Right here, we've got negative 1/2 times negative 2. The negative and the negative make a positive, and the 2's can cancel out, and 1 minus 3 does give us negative 2. So both of them check out, and they are both a solution. Moving on to the next slide, we're going to notice something about these two. When you look at them, what do you see in common? Now I know you're not going to answer me, but I'm hoping you would have said that the two of them have the same exact slope, which is 5/4. And we're going to see what that means if they have the same slope. Some of you might remember from before. So the first one, I'm doing this one right here. My y-intercept is at negative 1, so I'm going to go up 1, 2, 3, 4, 5, and over 1, 2, 3, 4. 1, 2, 3, 4, 5, 1, 2, 3, 4. And I'll connect them with an arrow on each end. Do the next one. We've got negative 2. We go up 5 over 1, or over 4, up 5 over 4. And what do you notice about these two lines? What kind of lines are they? You're right. They are parallel. Will they ever intersect? Nope. So if they never intersect, what would our answer have to be? No solution. So there is no point on the red line that is also on the blue line. Okay, now is when we get to the part where we actually have to do more work. very fun. So, give me a second. I have to plug in my iPad. I was naughty and didn't charge it last night. So, gonna zoom in. We have to take this one part at a time. So what I'm gonna do is I'm gonna remember what I said before, that they have to be in y equals mx plus b form. So I'm gonna work on the first one. Star it right here. I'm gonna get that into the y equals mx plus b form. So I've got 2x plus 3y equaling negative 3. I'm going to first move this 2x over to the other side by subtracting it, which leaves me with 3y equaling negative 2x minus 3. The last step would be to divide by 3 on both sides. And remember that 3 goes to both pieces over here. So it's going to be y equals negative 2/3 x minus 3 over 3, or negative 2/3 x minus 1. So in black, I'm going to go ahead and plot that one right away. So I've got my y-intercept at negative 1, and from there I'm going to go down 2 over 3, down 2 over 3, down 2 over 3. Connect your lines, or your points, arrows at each end. Then move on to the next one. Again, we need to get it into y equals mx plus b form. So we're going to take 7x plus 3y equals 12, and we're going to get that y alone. So we'll subtract 7x from both sides, and we'll be left with 3y equaling negative 7x plus 12. So now we'll divide by 3. Remember, when we divide by 3, it goes to both parts. So it's going to be y equals negative 7/3 x plus 12 over 3, or negative 7/3 x plus 4. So I'm going to go up to 1, 2, 3, 4. 1, 2, 3, 4. I can do this. And then I'm going to go down 7, down 1, 2, 3, 4, 5, 6, 7, and over 3. And I notice right away that that's where they're going to intersect, so I'm not going to draw any more lines than I have to, or any more points than I have to. And I'm going to highlight that intersection. If I found the coordinates, I notice there's one solution, one intersection point, and they do intersect at 3, negative 3. If you want to go through the check, you've got an x of 3 and a y of negative 3. So you could come up here, 2 times x was 3 and negative 3, and we'll see if that's what we get. Okay, go through the math and see if it works. Can do the same with the other one. 7 times 3 plus 3 times negative 3, and see if you get 12 for your answer. They do end up checking out. So let's move on to the next slide. Okay, and again, what form do we need to get these two into before we can graph them? Standard? No. We need to get them into y equals mx plus b form. So again, you choose which one you want to start with. I'm going to zoom in just a little bit. And I'm going to start with this one here. So I've got 5x minus 4y equaling negative 8. I'm going to subtract 5x from both sides, which leaves me with negative 4y equaling negative 5x minus 8. Last step would be to divide by negative 4. So y equals negative 5 over negative 4x minus 8 over negative 4. To rewrite that a little bit nicer, I can write y equals positive 5/4 x plus 2. I'm going to plot it right away. I went up 2, made a mark. Now I'm going to go up 1, 2, 3, 4, 5, and over 1, 2, 3, 4. I'm going to go in the other direction. 1, 2, 3, 4, 5, over 1, 2, 3, 4. Down 1, 2, 3, 4, 5, 1, 2, 3, 4. and I will connect now. So then I'll go to the next one. Do that one in a different color. So we've got x minus 4y equaling 8. We'll subtract x from both sides. So you have negative 4y equals negative x plus 8. Divide by negative 4 on both sides. So y is going to equal negative x over negative 4 plus 8 over negative 4. Or y equals, you could look at it as 1/4 x minus 2. So I'm going to go down to negative 2, and I'll follow the pattern up 1 over 1, 2, 3, 4. And I know they're not going to meet up along the way that way, so I'm going to reverse in the other direction, and you'll see that they'll end up crossing in one point, and that intersection is right here in black. Coordinates would be negative 4, negative 3. And there's only one solution. Here's your x, here's your y. If you want to, you can go back in, plug them in, see if it works. So you've got 5 times negative 4 minus 4 times negative 3, and see if that equals negative 8. Negative 20 plus 12 does equal negative 8. And on the other one, negative 4 minus 4 times negative 3 equals 8. Negative 4 plus 12 does equal 8. So that one checks out. Okay, so moving to the next one, again, I'm going to zoom in. Think about it. What form does this have to be in order for us to actually graph them? We need them in y equals mx plus b form. So I'm going to work on the first one. X minus 2y equals negative 2. First subtract x from both sides, which leaves me with negative 2y equaling negative x minus 2. Divide by negative 2, and y equals negative x over negative 2 minus 2 over negative 2. If I wanted to rewrite that, y equals positive, we'll call it 1/2 x plus 1. So I'm going to graph that at plus 1, and up 1 over 2, up 1 over 2. I probably don't need to keep saying that. Okay, so then I'm going to move on to the next one, get it into that important form, y equals mx plus b. So I've got 3x minus 2y equaling 6. I'm going to subtract 3x from both sides, and I'm left with negative 2y equaling negative 3x plus 6. Last step, to divide by negative 2, and y equals positive 3/2. I just saw I have a negative and a negative, so I'm going to make it positive 3/2 x plus, I've got 6 over negative 2, so I could write that as y equaling 3/2 x minus 3, or plus negative 3, however you want to look at it. So I'm going to go down negative 1, negative 2, negative 3, make a mark, and that's 3/2, so up 1, 2, 3 over 2. Up 1, 2, 3 over 2. And I found my intersection. Highlight that. I probably should make my line here. They've got one solution. They cross in one spot, and it's 1, 2, 3, 4, 3. So we've got a solution of 4, 3. There's my x, there's my y. You know how to check your work. Plug them in. 4 minus 2 times 3, and check if that equals negative 2. We've got 3 times 4 minus 2 times 3, and see if that equals 6. Moving on. I'm going to have you go ahead and download your homework. Okay, your homework should be the worksheet for M1, which will be due tomorrow. If you need to, email me at, let me write it down for you, sullivan719@yahoo.com. As long as I'm feeling okay, I will be able to get back to you as soon as possible. If you want to set up a time to FaceTime, you can also do that. So you'll just need to let me know. I'm hoping that I will feel okay and I will be able to FaceTime and answer any questions. But hopefully you understood this and the M1 homework will go okay. Yep, I will see you tomorrow. Bye-bye.